Hello friends, welcome to our channel. Let's look at today's daily challenge problem. Count total number of colored cells. This problem actually is more math than coding. So here we write the solution out directly. So this is the final solution, just one line of code. So here the thing is how to derive this formula, right? So first let's quickly look at the requirement. So we are given a two-dimensional grid of uncolored cells. So also we are given a positive integer m. So at first we color any arbitrary unit cell as blue, and then every minute thereafter color blue every uncolored cell that touches a blue cell edge. Actually, this is the requirement. If you look at n equals 1, so just 1, and then there are 4, so you get 5, and this one you get 13, right? So what we want to return is the number of colored cells at the end of n minutes. So here I'm going to do it by mathematical induction, right? Let me see, mathematical induction. So I'm going to call the result as fn, right? Given. So let's first look at n equals 1. When n equals 1, so we have f1 equals 1. So and when n equals 2, so let's count, right? So f2 actually equals, so we add something from f1, because here there are 4, this is the 1. So if you look at this 2, right, and this 2, and this 2, and this 2, there are 4 2s, but you count the 4 corners twice. So basically you have 2 times 4, so minus 4, right? Then n equals 3, what do you get? You get f3 equals f2 plus, so here you have 3, you have 3, you have 3, you have 3, so 4 3s, so you have 3 times 4. Notice that here is 2, here is 2, here is 3, here is 3, and then minus 4. So in the same fashion, actually, you can compute n equals 4, right? So f4 will be f3, right? So at this, you have 1, 2, 3, 4. So 4, 4, and 4, 4. You are going to get 4 times 4 minus 4. So basically, what you can write one step further. This is the f1 plus, so 2 minus 1 times 4. So here it's f2 plus 3 minus 1 times 4. So here you get f3 plus 4 minus 1 times 4, right? So if you write continuous, so you get fn minus 1 equals fn minus 2 plus n minus 1 minus 1 times 4, right? Then you continue, fn equals fn minus 1 plus n minus 1 times 4, right? So now let's look at this. So I'm going to delete this part so that I can align all of them. Let me also delete this part in the middle, so you will see what we get, right? So here and here. So now what we get, so you can regard this one as 1 minus 1 times 4, right? So we add the left hand side and add both sides together separately, respectively. So what do you get? So the left hand side will be f1 up to fn minus 1 plus fn, right? Then the right hand side is nothing but, so you see 1 plus f1 plus f2 plus, right? So 1 plus f1 plus up to n minus 1. Then you have 1, so 1 minus 1 times 4 plus up to n minus 1 times 4, right? Because left hand side equals right hand side, right? So those actually f1 up to fn minus 1. So here f1 up to fn minus 1 cancels. So this part. Therefore, what we get is left hand side only have fn remained. The right hand side would be 1 plus 1 minus 1 times 4 plus up to n minus 1 times 4, right? So the summation of this one is rather straightforward. Let me write in terms of summation with respect. So let's see, j minus 1 times 4. So here the summation is j from 0 less than or equal to n, right? Then this is just a very simple summations. So let's compute that. Fn equals the 1. So notice that I can also start from j equals 1, because when j equals 0, so here, we should start from 1. So here we have, because the 4, we can just get out those, right? 4 times, so 2 terms. So 1 plus 2 plus up to n, right? Then minus 1 plus 1 plus n terms, right? So this will be 1 plus 4 times. So summation from 1 to n is nothing but 1 plus n times n divided by 2, then minus this n, right? So then we have 1 plus 2 times n times 1 plus n, then minus n. So overall, we will get 2 times n squared plus 4 times n. Let's see, 2 times n, right? So here, let's see. Here we have a 4, right? We need to get this 4 times n. So 2n minus 4 times n. So here we have a 4 times n. So overall, it will be 2n squared minus 2 times n. Don't forget this one. Let's add it here. So we get this. That's 2n squared minus 2n plus 1. So that's the 2n squared minus 2n plus 1. Yeah, that's actually the final output to this problem. Now let's test it directly. Yeah, it passes all the cases. Needless to say, the time and the space complexity are both O1, right? So with that said, I guess that's it for today's daily challenge problem. Thank you for watching.